My name is Neil Wellfield. Welcome to my talk about Sequoia. Sequoia PGP is an OpenPGP implementation, and today I'm going to talk about a practical introduction to using SQ, which is our command line tool. But before we get into SQ, I want to talk about what Sequoia PGP is. First of all, it's an OpenPGP implementation. OpenPGP is an IETF standard, so it's a wire protocol. And it defines what encrypted messages look like on the wire, what signatures look like, what certificates look like. So it's pretty low level. So we have a low-level library at the bottom. This is the implementation of OpenPGP, and it provides an interface to applications. By itself, a wire protocol is really low level, and there's a lot of logic that you want to add on top of it. So we built a whole bunch of OpenPGP infrastructure. There are higher level libraries. There are services like daemons that run on your computer and provide a smoother interface. It's also privacy and security tooling. So SQ is a command line interface, it's a tool. This is an example of one of the tools that we have, but we also have other tools. And we also are interested in doing privacy and security applications. The Sequoia project is 8 years old. So we exist already for quite a while. And we built these first 3 things out pretty well now. And in the next few years, we hope to work our way further up the stack and try to improve the applications that users actually deal with. The goals that we started with 8 years ago were to build software that is, first of all, secure. That's critical, right? This is a security critical component. Journalists use this, activists use this, people can die. We want to make it robust. That means that in the face of unexpected situations, the software doesn't necessarily fall over. It should be usable. This is one of the tricky parts in security software. In security, you have to talk to users. It's about not only the technical things, but also whether or not the user understands what they're doing and the software is actually doing what the user wants. And so you need to connect the user in the loop. And so we put a lot of effort into making not only our library APIs easy to understand for developers and hard to misuse, but also in SQ, we invested a huge amount of time trying to make the command line interface understandable. And the other thing that was really important to us was being interoperable. So OpenPGP is a standard. There are about 10 different OpenPGP implementations today, and we want to interoperate with them. We want to implement the standard, and we want to do it correctly. The design of Sequoia is that it's a library-first approach. So in other OpenPGP implementations, they have a command line interface at the bottom, and then they have a library on top. So if you have an application, you talk to the library, and the library invokes the command line tool. In our case, we decided that this has a number of disadvantages. In particular, it's less robust, and the command line tool has to provide the entire API surface that the library provides. So we provide a library-first implementation, and as we work our way up to the stack to the command line interface, the command line interface is more adapted to humans and less to computers. At the low-level library, we have unopinionated low-level interfaces. Unopinionated means that we don't take a position on what the right thing to do is. You can do a lot of stupid things. But in order to make it harder to do the wrong thing, we try to make our interfaces safe by default. That means that the easy thing is probably the right thing. And if there really is something that you want to do that maybe we consider dangerous, maybe you have a good reason to do that, you can still do that. It's just a little bit more tricky. And so by adding that hurdle, we are consistent with people's laziness. People want to do sort of the easy thing. And so we make the easy thing the safe thing, and we're safe by default. On top of our low-level library, we have some other services, and these are more opinionated. So we have ideas about the right workflows. And if a consumer of these higher level interfaces is unhappy with the higher level interfaces, our opinionated interface, they can still use the lower level interface. And we've actually gone to great pains to make it easy to do, because our higher level interfaces are built on top of our low level interfaces and actually expose these lower level types up the stack. It's really easy to tweak the type of things that you want to do and still 95% of the time use the higher level interfaces. So it's not A or B, it's actually A and B. You get the best of both worlds. And then we have these optional services. So for instance, an application, you might have 5 or 6 that all use OpenPGP on your computer. You want a shared certificate store. You don't want to have to manage all of your certificates and each of your programs separately. That you want to be shared. But if you have a server program and it has a database, then you don't want to be using a certificate store. You have like another component. You're the only one who's using this database. You want to add a new column to the database with the certificates for the users. Then you opt out of that particular service. And the other thing that we've tried to do is to look at existing paradigms. OpenPGP exists for over 31 years. And there are common workflows that people do and conceptions that people have about how one ought to use these types of tools. And we spent a fair amount of time rethinking it. And the biggest thing that we've tried to change is moving from a certificate-centric approach to a user ID or contact list approach. So if you look at most existing OpenPGP implementations, they present certificates first, and then you can, from a certificate, you see the user IDs that are associated with the certificate. And we try hard to flip that upside down. So you first think about user IDs, and then there happen to be certificates associated with those user IDs. Now it seems like, okay, is that really important? It turns out in the user interface, it does kind of make a difference in the way people think about it. And based on the feedback we've gotten so far, it seems to be easier to use and easier to understand, particularly for people who aren't really, really deep in OpenPGP. So here are some of the components that we have. You can see at the top we have OpenPGP, which is our low-level library. We also have PGP cert D, which is a IETF draft document that explains a disk format that other OpenPGP implementations also implement. So it's shared. So if you're using, for instance, PG Painless, can also use this data structure. And then on top of PGP cert D, we have cert store, which is the more higher level Sequoia interface that manages things in memory and does it a lot faster. Then we have a key store for managing the secret key material, whether that be in a file on disk, or whether it be using an HSM like an OpenPGP card or a PKCS11 token. We have a web of trust engine. We have a library for accessing the network, for instance, doing lookups on key servers or WKD. We have a library for using autocrypt data structures. And we have a cryptographic policy, which is a nice way to define locally on your machine what algorithms you're willing to trust. And so we have defaults that we think are good, but different distributions have their own ideas of what reasonable defaults are. So for instance, if you run Red Hat Enterprise Linux, they ship their own cryptographic policy that disables some of the things that we allow. Okay, so on top of that, we have SQ, which is our command line tool. And that uses all of these higher level services and also uses the low level library directly. And then we have SQV, which is a very simple verification tool. And this is used by, for instance, apt in order to check package signatures. And it doesn't use any secret key material because it's only checking the signatures. So it doesn't need to access the key store. It doesn't need these other services. It's very simple. The program itself is only about 300 lines long. And it has its own trust model that's expressed on the command line interface. So, and finally, it respects the crypto policy. And this is nice because it makes it smaller in terms of binary size, but more importantly, the trusted computing base is smaller. So there are fewer things that can go wrong. So some users of Sequoia, there's apt. So if you're using Debian, then you're using Sequoia. If you're using Fedora or Red Hat Enterprise Linux, you're using RPM and you're using Sequoia. Secure Drop is a whistleblowing platform that uses Sequoia. There's Anon.io, which is a mail forwarding service that can encrypt messages on receipt. It uses Sequoia. The Swiss government has a program called SET that they use for exchanging medical data. That's based on Sequoia. Cubes uses Sequoia in their infrastructure, and there are a bunch of others. Okay, so what is SQ? Now we're getting to the core of this talk. So first of all, it's a command line tool. And it has a subcommand style interface. And the subcommand style interface is nice because it does a nice partitioning of the argument space. If you have, for instance, an argument like recipient, that only makes sense in the context of certain commands. And so if you have a whole bunch of commands and they're all mixed in with all of the arguments, then it's unclear, like, okay, now the user set recipient, but they're making a signature. Does that make sense? Is it relevant? And so using a subcommand style interface partitions these things, and it makes discoverability a lot more easy. SQ has a high-level interface. It explicitly does not try to be everything to everyone. It does a whole lot of things. It has about 50 commands. Most people won't use most of them, but some of them are needed sometimes. And if it still isn't enough, our recommendation is that you write your own program and use our libraries. You don't use SQ. We don't want to pollute it with things that nobody uses or very, very few people use. So the focus really is on these end user workflows. And SQ has a stable CLI. So we spent years developing it, and this past December, we finally released 1.0. And the last year or two was a very painful process for a whole bunch of projects who were actually using the 0.x version of SQ because we kept changing the arguments. And we apologized to them, but we said future you is going to be much happier because the CLI is going to be so much nicer. And we really spent half a year just moving arguments around, renaming things, trying it out, getting feedback from users. And now, 8 months later, I still feel really, really good about it. And yeah, we found a couple of small issues, but they're small. So I'm really happy with how the CLI came out. So it can be used for scripting, but it's not really intended to be used for scripting. People do it, so we want to support them. And so we have here this --CLI-version option. And this allows a script to say, I want version 1.2 of the CLI. And so if you happen to be running SQ 1.1, this will error out. It won't do it. It just won't run. And if in the future we decide to release SQ 2.0 with a new CLI that's not backwards compatible, we'll be able to provide 2 entry points. One for 1.x and one for 2.x, which provides a beautiful backwards compatibility story. And finally, SQ operates primarily in a stateful mode. You have a shared certificate store, you have a shared key store, but it can also be run in stateless mode. And this is nice for doing experiments or writing a bug report or doing something in isolation. All right, let's get to the demos that I promised. These demos were all done using SQ 1.2. We're now at SQ 1.3.1, so this is a couple months old, but nothing has really changed. I have trimmed the output because sometimes it's a bit longer, it doesn't fit on a slide, and I want to emphasize things. But I've tried to do so in a way that's fair to you. I'm not trying to misrepresent SQ by having trimmed some output, it's just in order to make it more readable. So, 5 main demos. I want to verify a download. I want to sign a message. I want to certify a certificate. I want to show you a little bit about certificate management. And I want to show you how to create and use a CA, a certificate authority, which might surprise you because OpenPGP is all about a decentralized trust model. But decentralized doesn't mean that you only rely on people directly. You can still use people as trusted introducers, so indirection. And a trusted introducer is just a CA. So let's first look at verifying a download. In this demo, we're going to try to download a Cube's ISO image, and we want to verify the signature. So SQ has a command called sqdownload. It downloads both the signature and the file. It verifies the signature and only releases the file. So it only saves it to disk if the signature is valid. So if the signature is not valid, or we can't authenticate the certificate, it's not saved to disk. All right, so let's do try number 1. We just naively go to the Cube's website. We find the URL for the ISO image. We find the .asc file for the signature, and we're going to save it to cubes.iso. And immediately we get an error. Immediately, right? We really immediately get an error. First thing it does is it checks the signature, and it says, we can't verify the signer because we don't actually have the certificate. All right. So how do we get the certificate? We have a command called sqnetworksearch. And before it told us what the fingerprint was that we can figure out from the signature. And so we searched for that, and then we find on the key servers that there's a certificate, and then we import it, and so we're good. And I want to call your attention to something here. Specifically, it says, if found it via keys.openpgp.org, keyserver.ubuntu.com, and sks.whatever. So SQ actually goes out onto 5 different key servers and checks them all. It also goes to WKD and Dane all simultaneously in parallel and downloads whatever it finds. You don't have just one key server, you can have them all. And then it merges them. All right, so for now we're going to ignore the next part, and we're just going to naively try again, because now we have the certificate, we solved the problem. So we're going to run the exact same command. And again, immediately, before it downloads the ISO image, it downloads the signature, and it says we can't verify the signature because we can't authenticate any of the alleged signers. Here we see Cube's OS release 4.2 signing key. It's unauthenticated. Damn. What does that even mean, unauthenticated? So authentication is about saying that something is true, that we believe something to be the case. In the case of OpenPGP, the thing that we're interested in is we have a certificate. Does this certificate actually belong to, is it controlled by the Cube's team? Maybe it is, maybe it's not. Anybody can create a certificate. And anybody can create a certificate that says Cubes on it. So I can't trust the user ID by itself. So how do I find out whether or not this certificate, which says it belongs to Cubes, really does belong to Cubes and not to somebody else? So I could go ask a friend. Maybe I know somebody who understands this stuff. And they say, oh yeah, that's the right certificate. Trust me. All right, that's a trusted introducer, right? So I'm delegating this to somebody else who I think is more knowledgeable than I am. That's legitimate. I do that all the time in my real life. We do that all of the time. I go on a bus, I delegate my safety to the bus driver. I could go ask a Cube's community member. I could even go to the stand here at FrOSCon and talk to the Cube's people and say, what's the fingerprint for your release key? Or I could go to the website, and here we see the Cube's release signing key, and I could download that. Now, exactly what you should do depends on your own personal threat model. So if you're a sort of normal individual, maybe going to the website is enough, because if you go to the website, you now assume that the website is correct. You're relying on the X509 PKI. Do you want to do that? I don't know, maybe. If you're more paranoid, if you're Edward Snowden or somebody else, you probably don't want to do that. And then you want to go ask a friend or ask a Cube's community member. So it depends on your trust model what degree of authentication you require. But we're going to assume, in our case, that we go to the website and we're happy. And so what we're going to do is we're going to run sqpki link add. PKI stands for public key infrastructure. And we're creating a link between the certificate and all of the user IDs. So here you can see certification created. But why do we call it link and not certification? So link is a term that we kind of invented because certifications cover a whole broad spectrum of things. You can have certifications that are public, and you can have certifications that are private. And one of the problems that people have with OpenPGP and the whole web of trust is they say, oh, you expose your whole social network. Well, you don't have to expose your social network, right? You can do all of these certifications locally, and your software will not export them. And if you try to upload it to the key servers that exist, they will automatically discard certifications that are marked as local. So you don't have to expose your social network. This is a local operation. And because it's a local operation, we didn't actually have to enter our password or anything like that. We don't even have a certificate yet, by the way. What we did is we created, and you can see it here, a local trust root. And the local trust root is just an OpenPGP certificate that SQ automatically creates the first time it does one of these operations. And then it uses that to create the certifications. So no passwords required. OK, so we look at our certificate, and we do sqcert list. We add the option show paths. And we see that the Kubes release 4.2 signing key user ID has a check next to it. It's authenticated now because we created the link. And we also see why it's authenticated, because here we have our local trust root. And a few months ago, we created a binding, a link, between the certificate and the user ID. We remember that for the future as well. All right, try number 3. What happens? Exact same command, nothing changed. All right, so first we pre-check the signature just like before. Everything looks good. Then we download the 7 gigabytes of data, and then we check the data. And here we see we're authenticating it. So, and then we have the path. So every time we do a verification, we also understand why something is authenticated, which is essential for users to have a good model of the system. It's not simply a binary yes or no, but it provides insight to the users. That way they have a good model of what's going on. Ah, yeah, back then, January 31st, I created this link between this certificate and that user ID. Yeah, I remember that. And then we see one authenticated signature, and the cubes.iso file is there, and we can use it. So to summarize, SQ download combines these different operations. It fetches the file, it gets the signature, and it performs the verification. The user still has the burden to authenticate the signer, to make sure that the certificate is the one that it should be. That burden is the first time. So if we were to download in a couple of months a new version of Cubes, we wouldn't have to do that, assuming that they're still using the same certificate. But that's our threat model, is that we want to actually authenticate this thing. And then we're careful to only actually release the data if it's authenticated. All right, sign a message. So the first operation we didn't actually have a certificate. You don't need to have your own certificate to verify signatures. Now we want to sign a message. Maybe we want to sign a message to our friends, or we want to release some software and we want to sign the tarball. Now we need a certificate, and we need to make it available to the recipient of the message. So how do we generate a certificate? Here, we see the command sqkeyGenerate. We provide a name, we provide an email address, and we say that this is our own key. The other option is to say that this is a shared key. But this is our own key. So it's fully trusted. We see that the certification is created immediately between the certificate and the two different user IDs. Well, that's interesting. If you know OpenPGP, most people use one user ID for this. Why use two user IDs? Well, when I check somebody's ID or I send them and check their email address. Those are two different things, right? So I can check one without checking the other. And when I create a certification, I want to be able to, for instance, only certify the email address and not the real name or the pseudonym or whatever it is. And so by creating two separate user IDs by default, this is possible. And there's another motivation as well, which is most people are probably familiar with Let's Encrypt. And so Let's Encrypt has a mechanism to sort of automatically create certifications if you can prove in a machine readable way that you own a particular certificate. Well, we can do the same thing with email addresses. And if you use keys.openpgp.org, when you upload a certificate to keys.openpgp.org, it sends you an email and it says, is this really your certificate? And so in theory, keys.openpgp.org could also create a public certification over the email address, which it just checked, right? Because you clicked on the link and you certified, this really is my certificate. But keys.openpgp.org can't check the person's name and doesn't even want to. So we want to keep these things separate. All right, so we generate a certificate. This is what it looks like. And look at this, we even get some hints down here about what we should do next. One thing you could do is you could export the certificate to a file, and then you could attach it to an email. Or you could publish it on a key server using SQ Network Key Server Publish. So users don't need to memorize all of these commands and necessarily follow recipes online because the recipes are already embedded in the output. All right, we have our certificate, and now we want to sign a message. We use SQ sign. -- signer specifies which certificate we want to use, and then we get the message. And it's signed, and then we can use another command, SQ verify, to verify that indeed the message has a signature that's valid and it comes from our certificate. All right, so that wasn't too complicated, I hope. Now, -- signer fingerprint, that's kind of inconvenient every single time, so you can add to your configuration file the default signer. What if we want to do a detached signature, which is how people usually publish software? Well, we can use SQ sign, and now we specify a -- signature file, and that's where it's going to be saved. And we specify the file that we want to sign, and we get the detached signature. And again, we see similar output. We do SQ verify, we specify both the signature file and the file that we signed, and we see that it's authenticated. So, I talked before about certifying signatures. How do we do that? We talked about link, which is a local assertion. That's not exported. It's not published. The other term that we have is vouch. Somebody is vouching. I vouch for Ada that this is really her certificate. So a vouch is a public certification that's published online. And so we use different terms in order to try to avoid confusion so people have something separate in their mind. Okay, so Ada vouches that Charles has a certain certificate. That's what we want to do. First we find Charles' certificate. So we do SQ network search, and we get back one certificate, or maybe we get 10 certificates, who knows. And for whatever reason, just like before with cubes, we know, we verify, we check that this is indeed the correct certificate. With SQPKI link add, we only had to specify the certificate and the user IDs that we wanted to link. Now we also have to specify a certifier because we want to make a public vouch. So we need to specify which certificate we want to use. So Ada specifies her own certificate. And again, we can also use our configuration file in order to specify a default. And this certification is created. Okay, let's take a look at Charles' certificate. We do SQ cert list and show paths. And so Ada sees, okay, the user ID is authenticated. And now we can also see why it's authenticated, just like before. We start with our local trust root. Here we have Ada, and then Ada goes ahead and she certified Charles. Okay, that's cool. What's interesting is that it's multiple hops, right? So before we had the local trust root directly certifying Ada, and that was good. And now we have something in between. This happens to be Ada's certificate, so it's maybe not so surprising. But Ada is acting as a trusted introducer here, because the only thing that SQ actually really trusts is the local trust root. And she has certified this certificate and user ID pair. All right, let's move to key management or certificate management. So you create a certificate and you use it for a few years, and all of a sudden it's about to expire. What do? It's pretty easy. You don't need to use a complicated how-to. You just do SQ key expire. You specify the certificate. You specify the expiration time, in this case 3 years, and you're done. Maybe you have to enter your password. And then you publish it on the key servers, and everybody finds out about the new extended expiration. All right, we simplified that workflow. I'm happy about that. But let's look at something a lot more complicated, which is you want a new certificate. Ooh, why do you want a new certificate? There are different reasons. Maybe somebody got access to your computer, and now you're not so sure that your secret key material is safe. So you need a new certificate. Or maybe the certificate is old. It's 5 or 10 years old. It's just time for a new one because technology has changed. Algorithms that were once considered safe are no longer as safe as they could be. Okay, you want a new certificate. You need to generate the new certificate. You want to make sure you use the same user IDs, and you probably want a similar structure. You need to link the new certificate, SQ PKI link add. You probably want to cross-sign the old certificate and the new certificates. That way people who have your old certificate can find out about the new one. And, oh, there are all those certifications that you made. We should probably replay them onto the new certificate. Like Ada certified Charles, so she should do it again using her new certificate. And don't forget, retire the old certificate. Maybe not immediately, but maybe do it in 6 months. All right, so that's a lot to unpack. So you can imagine that this is going to be really complicated. But you would be wrong, because SQ provides a single command that does all of these things, which is the thing that you want it to do. There's SQ key rotate. It takes a certificate, it cross-signs the old and the new certificates, it replays the links, it replays the certifications, it retires the old certificate in 6 months. Easy peasy. We talked about how Ada sort of acted as a trusted introducer, but maybe you run a website, or you have a domain, you're a company, you're a bank, example.org, and you want to make it easy for your customers to authenticate all of your employees. So you want to create a CA for your bank, or your website, whatever. Okay. So how exactly does that look? We want to create vouchers for members of the organization. That means that you have an admin inside of the organization, somebody who's trusted. They go around and they collect the certificates from everybody, and they go to the CA and they enter all of the data. And this is an ON operation, right? The admin has to go talk to each individual employee. So ON, that's not so great. But the alternative is if you're inside of the organization, it's ON squared, right? If everybody has to talk to everybody, that's expensive. So this is a radical reduction by delegating to somebody and then configuring all of the employees to use the CA. But it's not only inside of the organization that we can save time. It's also outside, because the people who want to talk to people inside of the organization, they can use the CA as well if they have reason to trust it. All right, so we have, and it could be an activist group as well, right? So if you've ever gotten to know activists, and at some point the activists feel like, oh, we need to improve our OPSEC, there's usually one person in the group who is considered the expert, and everybody trusts that person. And maybe that person sits down and does a crypto party and explains to everybody how all this stuff works. Now, maybe one or two of the people, of the activists, understand what that person said, but most of them are like, okay, I understand superficially what's going on, but at the end of the day, I trust you. You're my friend. Delegation. We're delegating trust. This is a very human thing. And so the activists could also use a CA. There may be reasons that they don't want to do that, but in theory they could. Okay, so we create the vouchers, and then we want to be able to publish the certificates and the vouchers in a WKD, a web key directory, and maybe on key servers as well. And we want to keep them up to date, of course. So how do we create a CA key? Well, it's again SQ key generate. And when we create a CA key, the only thing that we're interested in is the primary key that has a certification capability. There's no need to encrypt messages to that. It doesn't need to do SSH or anything like that. So we strip it down and we make it as simple as possible. So it cannot sign, it cannot authenticate, and it cannot encrypt. All right, fine. So here's our certificate. It has one key, that's it. Here's the fingerprint. And then it has ca@example.org. All right, we create some vouchers. We saw how that worked before. We have the CA key. We specify -- certifier CA key -- cert is a certificate we want to certify. And we want to certify all of the user IDs. There are 2 user IDs in this case, so we certify ada@example.org and Ada Lovelace. And now we want to publish them. So we know how to publish on key servers. We saw that before. But we also provide a command to publish to a WKD. So a WKD is just a directory on a web server. It's under .wellknown. And you have to populate it in a particular way. And then anybody who knows the email address can go ahead, they find the right web server, they look in the right spot, and then they get the certificate back. So it has a particular structure. And the location is then unique because it looks at the domain, .wellknown, blah, blah, blah. Okay, so we want to publish this WKD. And we want to publish all of the certificates for our organization. So we start with our trust root, our CA. And we specify that we want to do the domain example.org. And we're going to create a WKD on the web server, example.org, and we're going to put it into the public _HTML directory. And we're going to use the rsync protocol. And so we can publish it. And we can use basically the same thing from a cron job. And so you can let this run every night and it automatically gets updated. And if we have a local certificate store that we're updating from, we can also go onto the network and pull in updates because maybe one of our employees or one of our members of our organization, they published a revocation certificate on a key server. Well, we want that in our WKD as well. So we'll pull that from the key server, add it locally, and then that will automatically be propagated to the WKD. And so we spent some time thinking about this. We feel like it's pretty easy. So now we're on the other side. We have the admin did all of the work, and now somebody wants to come along and use it. They want to use the CA. They want to talk to ada@example.org. So how do we encrypt a message? We can identify a certificate by its fingerprint. That's inconvenient. Or we can use an email address. That's what we want to do because that's what we know. So we do SQ encrypt for email, ada@example.org. And unfortunately, SQ encrypt says, oh, error. We could not resolve this user ID. And why is that? It's not that the user ID is not known. It is known. If we look at the error message, we can't authenticate it. That's unfortunate. So we could go ahead and we could get Ada's fingerprint and we could add it using SQPKI link add. But then we'd have to do the ON operations. So maybe there are other people inside of example.org that we want to talk to. Or maybe we can't even talk to Ada because she's just an employee at the bank and she doesn't understand this stuff. So we want to add the CA. And we don't want to just certify the CA because when we certify, we're only saying that the certificate and the user ID, they belong together. we're not delegating any authority to the certificate. When we have a CA, we actually want to delegate to the certificate. We want to say we trust this certificate, the person who owns it, to do certain things, to introduce us to other entities. So we use authorize, and that creates a trusted introducer. And here, so it's SQPK link authorize. It's a local operation. This will never be published on the network. We specify the certificate, and we also specify a domain. This is interesting. What does the domain mean? This is a scoping mechanism. So if I go to my bank.org and I use their CA, if I were to use it in an unconstrained way, they could introduce me. They could say, this certificate, this belongs to Jeff Bezos at Amazon.com or whatever. Oh, that's interesting. That's my bank. Why are they saying that? They have no authority to do that. So this is a scoping operation that says that this certificate I delegate to, it's a trusted introducer, but it's only a trusted introducer for user IDs or email addresses in the example.org domain. So that's pretty powerful, and this makes it relatively easy to do. And if you don't include -- domain example.org, you actually get an error. SQ does not like that, because that would not be safe. It would create an unconstrained trusted introducer. Safe by default means we're safe by default. Unconstrained, dangerous. So you either have to specify a domain, or you have to specify -- unconstrained in order to really opt into this more dangerous thing. Okay, so now we try again. SQ encrypt, we encrypt, and we're happy. So what exactly happened? What does that look like? So let's look at SQ cert list at example.org, and we show the paths just like we did before. We see now that it is certified. There's a check next to the user ID. We start with our local trust root as we have before. We see that the local trust root has a link to, for this certificate, ca@example.org. And not only is it a link, it is a trusted introducer, or a meta introducer in this case. And then the meta introducer said that ada@example.org has this certificate. And that's why we have the check mark. So those are the demos. What did we see? We saw that SQ supports a whole bunch of high-level workflows that are oriented towards users. SQ guides users with hints. Sometimes there are different things that SQ cannot know what the user wants to do, but it provides options so the user doesn't have to read the manual pages, doesn't have to follow a tutorial. SQ has some new concepts. We have this idea of a local trust root, we have links and vouchers, and we have this mandatory authentication. If you're interested in learning more, we have a book. You can go there, and we have a whole bunch of man pages. They're also on the web. And if you have any questions, I'd be happy to take them now. Do you want to bring the mic over? Okay. Go ahead.
Okay. You have this nice feature at the beginning that if you use SQ in scripting, then you can add the version that your script applies to. I imagine it could be quite cumbersome that if I've got a script with several SQ invocations that I have to repeat that in every line. Can I put it into an environment variable?
Right. So the question was, if I'm using the -- CLI version command line option, do I have to use it every single time I invoke it, which would be inconvenient from a script, or is there some sort of workaround? So the suggestion was to put it into an environment variable, and we decided not to do that, because if you put that into your, for instance, .bash profile or something like that, that would have some weird interactions. And if you call some subscripts that also use SQ but want to use a different version, there might be some conflicts there. So it's brittle. But what you can do is that if you're using, for instance, Bash, it has functions. So you can define a function SQ, and then it takes the arguments, and then it just simply inserts -- CLI - version 1 dot whatever you want.
So how much bike shedding went into this PKI link? Why is it called PKI trust, for example?
So how much bike shedding went into SQ PKI link, and why is it not called trust? So trust is a tricky word, I think. So what does trust mean? It's more about whether or not I'm willing to make myself vulnerable to somebody. So I think that's a better way to think about it, or the degree to which I'm willing to rely on somebody. Not trust is like, it's very fuzzy, but I'm willing to rely on you to do a certain thing. Okay. Let's figure out a new word for rely on. We wanted one word, things, and what you're doing is you're creating a link between the certificate and the user ID, and that's sort of where that idea came from, that locally you have a link. And a vouch, which is the public thing, that's something that people do in public, right? I vouch that so-and-so is trustworthy, for instance, a bad word. So that's where that came from. And we spent a huge amount of time, lots of discussion, is thinking about what are the best words. And I don't know that we came up with the best words. Probably they're better, but we had a limited amount of resources. We spent a lot of time on this, and maybe it's not ideal, but I'm pretty happy with how it came out.
You said that you have this nice download function.
Mm-hmm.
So that's the tool will only download the file if it verifies, or if it has everything to verify the file. Did I get it right that the tool really downloads it to RAM before if it's and only writes it to disk if it verifies, or so if I have a limited amount of RAM, 6.9 gigabyte was the example.
Mm-hmm.
Quite a lot.
Mm-hmm. Okay, so the question was, does SQ download first store the file in memory and only after it's authenticated write it to disk? For very big files, that could be problematic. And so what we currently do is we write it to a different file, to a temporary file, and then we delete the temporary file if it doesn't authenticate. And if it does authenticate, then we move it into place. Perhaps better approach would be to write it to disk and mask it. So you could use, for instance, AES, and you could encrypt it using some simple key, and then you've written it to disk, and then after you've authenticated it, then you would copy it, you would decrypt it and copy it to the correct location. So that would be sort of even better, but this seems to be sort of good enough, and doing the AES thing to mask the data adds complexity. I'm gonna go. Thank you. Beautiful work was the comment.
I also got a question. You are doing these network operations like downloading and so on in the same process than you do the cryptographic operations, right? Have you built in any provision to do privilege separation of different processes?
Right, so the question was, the network operations are in the same process as as SQ. And do we have any sort of process separation built in? So we have a number of different defenses. We have process separation. So we have the key server that runs in its own process. It's possible to, for certain things, it's not good to, like for instance, you have an init RD. It's tricky to fork and do some other things. So it's possible to co-locate it. And that doesn't actually change the interface for interacting with the server. But normally, it uses a separate process to talk to the key store, which has the secret key material. So the secret key material is stored there, and if you have a Heartbleed style attack, then you're still safe. The second thing that we do is that we encrypt memory. So all of the secrets are encrypted using a really big key. I think it's 64 kilobytes. I'm not entirely sure. OpenSSH does the same thing. So we have this really big key that's spread out in RAM. And so you have to first exfiltrate the key in order to then be able to exfiltrate the encrypted secrets, and then you can decrypt the secrets. So that's tricky. And of course, we, SQ, still need to access some of the secrets, like the session key material and things like that. So we decrypt it on the fly, and then after we're done using whatever it is that we decrypted, we clear the memory. So we zero it. And so the time that the secret's actually available is very short.
Related to the question about downloading, so I've often seen it that some projects distribute their code where they have the files, then they have a directory level SHA-256 sums, and then they have a SHA-256 sums.sig or something like that.
Yeah.
Do you support that?
So the question is, if a project doesn't directly sign the tarball, but has a file containing all of the checksums, and that's signed, do we support that? And so we support that in the sense that you can use SQ download to then download the checksum file and check the signature, which is not good enough. And we know that that's not good enough. And so this is a pending feature to add support for this mode of operation. So supporting checksum files explicitly in SQ download.
You talked about this nice feature that you have some certificates or public keys that you want to publish, and you can provision them using rsync immediately built into the command. And you said you're using the rsync protocol. That was quite surprising to me because most of the times when I use rsync, I use SSH as transport. So will it be rsync or is it SSH?
The question was when we publish a WKD and we specify rsync, are we using the rsync protocol or are we using SSH? No, we're using SSH, but when I said rsync protocol, I was thinking of the update protocol. Five minutes. A few more questions. Or we can all go home. Okay, I think we're going home. Thank you, everyone.